Hello dear students. In continuance of my previous lecture, today I will discuss about Galilean transformation. So, while I finished yesterday, I have finished that a new dimension is introduced in three-dimensional Cartesian coordinate system. With this new dimension, the positions of any point can be written as a set of space and time. So now we can say that we are in a four-dimensional space-time. Now, as yesterday, I have started with the two frames S and S prime. Today, today I will define the vector joining O and O prime. I can say this is the vector D. So, from vector addition formula, x, y, z, and this point is x prime, y prime, z prime. So, from vector addition formula, what can I write? I can write down vector r is equal to vector d plus r prime. Since I have taken the simplest case where the frame S prime is moving with a constant velocity along the x direction. Okay, so I have taken the velocity u is equal to ui. This is the simplest case. And here the axis of two frames are parallel to each other. So this is my case. Now, what is r vector? R vector is xi plus yj plus zk. And what is d vector? You can see d vector is along x-axis. Now, another thing to mention, here the unit vectors unit vectors of both frames are equal. Here also I cap, j cap, k cap. We are measuring with the same scales in two frames. So, you can simply say that OO prime is equal to distance between two frames. So how? So what will be the distance? Since S prime frame is moving with velocity u, after some time t, And also here time is universal. Since time is universal, so t is equal to t prime. After some time t, what will be O prime? It will be simply velocity into time, u into t, or is equal to u into t prime. So this is our first equation. So our first equation is t is equal to t prime. This is my first equation and it is my second equation. Now further I can write down d is equal to O prime plus what is r prime? X prime I cap plus y prime z cap plus z prime k cap. Since O prime is equal to ut prime or ut, so ut and what is the direction? I cap plus x prime I cap plus y prime z cap plus z prime k cap. So is equal to what will be? X prime plus ut I cap plus y prime z cap plus z prime k cap. This is my equation 2. Now from both sides, if I just equate the directions, so along I cap, what I get? What equation I get? If I do x is equal to x prime plus ut. If I compare both sides along z cap, what I get? Y is equal to y prime. Along k cap, what I get? Z is equal to z prime. And previously, you already know that t is equal to t prime. Now, this set of 4 equations is called Galilean transformation. So here we have assumed that frame S prime is moving in the right direction with respect to frame S. So this Galilean transformation, when it is applicable? It is applicable when S prime is moving with uniform or constant velocity towards the right. Now, in physics, everything is relative. So, basically, we can say that there is a relative velocity between S and S prime. So, we can say this sentence in a different way. How? How differently we can say? We can say that the S frame is moving with a uniform velocity towards left and away from S prime. So the two sentences both are correct. Both are correct. But what is the difference? So the first one. So what is the first one? First one is this is according to the observer sitting at O. And this one, this is according to observer sitting at O prime. So when we are saying that S prime is moving, so when these transformations equations we have to apply, so this will be applied we will apply this when we already know x, y, z and t. When we already know x, y, z and t, then and we want to know x prime, y prime, z prime, then we will apply this one. So there is another set of equation. Just we simply, if we rewrite these equations, that we will call inverse Galilean transformation. Simply we want to know x, y, z, t when we already know x prime, y prime, z prime, t prime. Then how will you write? Just simply rewrite the equations. We know x is equal to x prime plus ut. So we will simply rewrite x prime is equal to x minus ut. Y is equal to y prime. Simply rewrite y prime is equal to y. Z is equal to z prime. We will simply rewrite z prime is equal to z. And t is equal to t prime. So these sets are called inverse Galilean transformation, and these are now these two sets of equations are our Galilean transformation. I have discussed a simple case where our S prime frame is moving with a constant velocity along x-axis. But these can be more complex. The situation can be more complex. But ultimately what we get this type of equation. So what will be the more complex equations? When we say S and after some time x, y, S prime is here. So nothing to worry. So similarly as previous, this is our point P. Okay. So this is our point P. This is our r vector. This is our r prime vector. Now the velocity is only different here. So what is the velocity here? Here the velocity of frame, which is basically u. So u is not ui, but what is u? So u is uxi plus uij plus uzk. So if this is the case, and this is our displacement vector d. So if this is the case, similarly, as I have discussed previous, we can write vector r is equal to d plus r prime. So similarly, displacement, what will be displacement? Vector u into t. So now vector u is ux t I cap plus ui t j cap t k cap. So you can write xi plus yj plus zk is equal to ux t I cap plus ui t j cap plus uz t k cap plus x prime I cap plus y prime j cap plus z prime k cap. So ux, ui, uz are the velocity component along x, y and z. Uy j cap plus z prime plus uz, sorry, there will be t. So when the frame is moving like this, we get this transformation equals, and finally what we get? X is equal to x prime plus ux into t, y is equal to y prime plus uy into t, z is equal to z prime plus uz into t. And since time is universal, t is equal to t prime. So these set are the Galilean transformation. Now, where we can use Galilean transformation? So Galilean transformation we can use in our everyday experience. That means Galilean transformation is basically it is applicable to Newtonian motion. And inertial frames. So when we are saying that applicable to Newtonian motion and inertial frames, that means the forces are invariant. That means the forces are invariant with respect to frames. So if in S frame some force is m into a, then in S prime frame also the force m into a. That means a is equal to a prime. So acceleration is invariant under Galilean transformation. So this is your homework. Prove that acceleration is invariant under Galilean transformation. So prove that using the basic equations of Galilean transformation. So try this at home, and tomorrow I will prove this in my lecture. Till now, stay home, stay safe.